All right. So good afternoon and welcome to the Google Cloud Lunch and Learn. My name is Ingrid Gonzalez and I'm the Google Cloud Sales Director. So on behalf of the Google Cloud family, I want to thank all of you for joining us in these very unique times. I hope that your family are healthy. This Lunch and Learn is part of the weekly Tech Talk series. Our goal is to engage with our customer and to serve you better. Previously, we covered topics such as business continuity, Google Meet, DevOps, and Kubernetes. This session, our goal is to be as interactive as possible with our customer, and we want to share with you some best practices. Every week on Wednesday at noon, we'll welcome you to join us to discuss new topics. Next week, on May 13, we'll discuss Terraform. And the following week, on May 20th, we'll have an Entos deep dive discussion. And we are looking forward to welcome all of you. We'll send you some link after the presentation today. So I encourage you right now on a YouTube live session to register and share with us your email. Every week, we'll send you a reminder of the event, the presentation, as well as a form for your feedback. We do value your feedback and we'd love to hear from you all the net new subjects you would love to have Google and cover for the next session. After today's presentation, you will have the opportunity to ask questions. So I encourage you, as soon as you can, to put your questions on a YouTube Live chat box. I'm very excited today to introduce you to two of our guest speakers, Cindy Quach and Betsy Beyer. Cindy is a site reliability engineer on Google Cloud SRE team. She works with Google Cloud customer to help them adopt SRE best practices and principles so they can operate more reliably in the cloud. Betsy Beyer is a New York-based technical writer at Google who specializes in site reliability engineer. She has co-edited 3 Google Book SREs. Our Google Runs production system, the Site Reliability Workbook, as well as Building Secure and Reliable System. We'll provide a link for free digital copy of this free book after today's call. So without waiting, I'm very excited. So Cindy and Betsy, you have the floor. Thank you, everyone.
Hi, everybody. Thanks for taking the time today to attend this lunchtime chat about SRE. I'm Betsy. As previously mentioned, I'm a technical writer, work at SRE, and I'm based in New York.
Hey, everyone. As Ingrid mentioned, I'm a site reliability engineer at Google. I've been at SRE at Google for about 7 years now, and I've worked on various teams such as our mobile infrastructure, our Linux distribution, and a bunch of other stuff. And I'm super excited to talk to you about site reliability engineering today and how you can adopt some of the best practices and principles that we use. So I want to talk a bit about this key term reliability in SRE. And I'm sure there's various reasons why you're all here. Maybe you're responsible for your service's resiliency. Maybe you have some scaling concerns, such as scaling your operations as your service grows. Maybe you have a large event coming up that you need to scale up for, or maybe you just have some general unavailability concerns for your service. So I really want to just have you take a couple seconds or a minute here to think about some of these concerns and what makes you nervous about reliability. And keep these in the back of your mind as we go through this presentation and talk about how to ease some of these concerns with the practices and principles that SREs use.
So in this talk, we're going to discuss 4 key areas. First, we're going to talk about the core problem that SRE solves and high-level organizational structures that facilitate the practice of SRE. Second, we're going to talk about the key principles SREs use to keep systems appropriately reliable. Then we'll talk about the key areas of responsibility and expertise SREs have. And finally, we'll summarize the essentials of SRE and discuss how to adopt SRE within your own organization.
So let's start by talking what SRE is, what the core problem SRE solves, and the high-level organizational structures that help facilitate the practice of SRE. And before I do that, I want to talk about the operational cost of software. Software engineering is typically focused on designing and building, and not so much on like operations, even though the cost of running the software once it's launched is far more expensive, and we've seen up to 10 times the amount of cost. And in our experience, organizations often focus on hiring really good software developers, but they don't really care so much about operations, and it's often seen as somebody else's problem. So already from the start here, incentives aren't aligned. So you have developers who are constantly building new features and wanting to get them released. So they throw them over this proverbial wall to the operations team, and then they move on to the next thing. And then our operators are juggling everything that's being thrown at them while being responsible for everything from reliability, scalability, and maintenance of the software. So in other words, you have developers who want to go as fast as they can, and then operators who want to slow things down as much as they can to reduce risk. It's a pretty terrible setup, and it's not really designed for harmony, and it's quite brittle and doesn't scale well. It also establishes silos within your organization. And there are some techniques we use to deal with this, right? There used to be a wall between product management and product development, and agile development solves this problem to an extent. And then DevOps came along roughly the same time as SRE, and it broke down this wall between development and operations to help folks achieve better reliability and agility. However, for SRE, what we really want is to take all three of these domains, the business, the development, and operations, to help us balance development velocity and reliability to align with our business goals. Essentially, this is the core problem that SRE solves. And we'll talk about how we do this throughout this presentation. And before I do that, let's talk about this term DevOps. We often see folks ask us what the difference between DevOps and SRE is. And essentially, both SRE and DevOps intend to solve the problem of reliable services at scale, but they've converged on similar solutions. So let's go ahead and just break down DevOps really quickly. There are many definitions for it, and here's my definition. So DevOps is a set of practices and guidelines that say, here's how you're going to break down these silos. So there's 5 key areas we look at here. The first one, it tells us we need to break down that wall between development and operations to help with collaboration and velocity. And the second is that we know things are going to break, right? We plan for them to break, and we accept that failure is a normal thing, and we want to mitigate this risk and manage it as best as possible. And the next thing is that smaller changes are easier to implement and deploy, which makes them easier to roll back, which helps with reducing the time it takes to repair them. We also want to remove human error from the equation as much as we possibly can, and we do this by having tooling and writing automation. And then finally, we want to measure everything, because measurement is super critical to determine the success, especially in the above 4 areas that I just mentioned. So throughout this presentation, we'll see how SRE implements each of these practices. So how is DevOps similar to SRE in this regard? So at SRE, we say that we use data to guide our decision making, and we treat operations as a software engineering problem. And to do that, we have to hire folks with software engineering skills who are not only capable, but are also motivated to automate a lot of the tedious operation tasks away. And we also know that we need to design our systems to be reliable from the start, rather than adding something on at the very end after your systems are already built. And so what do SRE teams do? So in a nutshell, we write software and design systems that operate scalably, reliably, and efficiently. It's really a combination of 3 things. You have a group of people, a set of philosophies and mindsets, and a set of engineering practices and tooling. And you really need all 3 of these things to have an SRE team. But while you need these 3 things, keep in mind that not all SRE teams are made the same way, and they really differ in like many different ways. They can vary in how they're organized and implemented, and they can vary in their maturity levels. This could range from having like an everything SRE whose scope of responsibilities is very broad. And this is really a common implementation when starting up SRE at an organization. Or you can even have SREs for specific products and applications, such as Gmail or search. And so there are just many different ways to organize SRE teams. Even within Google, this is true. Gmail has been around for ages. They have their own dedicated SRE teams, and they're spread across the globe to have the most efficient coverage. On the other hand, there are newer SRE teams at Google that only have 1 to 2 SREs who are just embedded into a developer team. So it's not a one-size-fits-all solution. And like I mentioned, SRE teams will differ in many different ways. So now that we've learned a little bit what SRE is, we can start to answer this question of what is the difference between SRE and DevOps? DevOps is really a cultural practice to break down the silos between various teams. And site reliability engineering is a set of those practices we found that work and we've made into a job role. Remember, our approach to operations is to use data to guide our decision making. So going back to the problem we had at the beginning, where we want to balance development velocity with reliability while at the same time aligning with business goals, we do this with quantitative data. And that actually brings us to how we do that in our next point.
So our next point is about error budgets, which are probably the most important core principle of SRE. So to talk about error budgets, we have to talk about reliability and specifically about how to measure reliability. The simple and somewhat naive way to do this is by measuring how much time things were good overall in the measurement window. This is nice. It's intuitive to understand. It's fairly easy to measure things that are continuous. So for example, if you're dealing with a web server, is it up or is it down? This simple approach doesn't work as well for more distributed and complex systems. For those kinds of systems, you need fancier definitions of reliability that can also handle whether your service is partially up or down and to measure the quality of service. One approach is to look at the number of good interactions over the number of total interactions. What's important here, though, is to have a definition for reliability and a way to measure it. So again, we keep coming back to you've got to measure everything here. The next concept here is that there's a certain amount of reliability that you're trying to reach. You've probably heard of a 3 nines or 4 nines service. This type of measurement's really about the amount of downtime that you're willing to tolerate. So here on this slide, we have a nice chart, and it maps different levels of nines to how much unreliability you're allowed to have per 30 days, per quarter, and per year. But remember, here you're thinking not just about time being hard down. A hard down's an assumed 100% outage, and there's a lot more nuance and room to maneuver if you can measure brownouts and not treat them as either 100% errors or 0% errors. So looking at this chart, you might be thinking there's a number missing on the chart, which would be 100%. But the key realization that Ben Trainer-Sloss, the founder of SRE here at Google, had was that 100% is almost always the wrong reliability target. And this is really where error budgets came from. So what do we do instead of aiming for 100% reliability? You really need to pick a reliability target that's going to meet the needs of your users. Are people even going to notice things being down? Figuring this out is mostly a project management concern. So the amount of unavailability you're willing to tolerate is your error budget. And of course, you need to measure that unavailability. And then once you know how much of your error budget you have left, you can choose how you're going to spend that error budget. For example, you might want to ship new features or perform experiments. So this is a really powerful concept. You now have an objective way to measure reliability and whether or not you're meeting your agreed upon business goals. Suddenly, you should be finding that both developers and SREs are looking to balance development velocity with reliability. Both sides are working together, devs are empowered to manage the risks themselves, while likewise, SREs know what to focus on, either improving reliability or other things they also care about, which we will talk about soon. So when we talk about error budget, it really boils down to three terms: SLI, SLO, and SLA. So the SLI, service level indicator, tells you at any moment in time how well your service is doing and if it's performing acceptably or not. The SLO, service level objective, aggregates that over time. It's a mathematical equivalent of error budget. It says that over this certain window of time, this is my target and how well I'm doing against it. And finally, the SLA, service level agreement, is mostly relative to a business. So it defines what you're willing to do, such as refunding money if you're failing to meet your objectives. Defining SLOs is a super complex topic, and we can't really describe all the nuances in the time we have here today. But really, the most important thing to remember is that you need to come up with a simple SLO first, and then iterate on that SLO over time. So you can use a primitive metric to set priorities and then decide what you want to do. Some questions you'll need to ask as you develop your SLO include: where's your SLO document? How do you know that the SLO matches customer expectations? What is your SLO review process? How do you consider your SLO and your system design process? And finally, how do you measure SLO compliance? So SLOs require buy-in from business, development, and operations. They bridge all three domains and give them a common language, unlike just pure Agile or DevOps. So with just SLO and error budgets, if we look back at that 5 key areas of DevOps list that Cindy mentioned earlier, we've already covered 3 of those 5 key areas, numbers 1, 2, and 5 on this list.
So now that we've talked about what SRE is and the problem we're trying to solve by balancing development velocity and reliability while at the same time aligning with our business objectives, we now see how we can do this with quantitative data using SLOs and error budgets. So now, instead of trying to figure out whether a development team can release or whether they are holding back a release, people aren't yelling across the table to get their features pushed. Instead, they have this quantitative data that they can use to justify product and business decisions, right? So now that we have SLOs and error budgets, how do we actually defend them in our day-to-day within SRE? So there are a few key practices that we look at. So you have metrics and monitoring, you have capacity planning, change management, emergency response, and the last one's going to be a cultural change that you have to make within your organization. So let's talk about monitoring and alerting. So Betsy mentioned this earlier when measuring your SLOs. This is where monitoring and alerting is super important because you need to measure how well you're doing against your reliability targets. You need to have high quality alerts that only fire when your error budget's threatened. One really common alerting situation I see is on-callers will get paged for alerts that, 1, they can't actually fix, 2, might be an existing problem, and 3, they just flat out ignore it. I mean, how many of your Slack channels are filled with these type of alerts, right? This is bad for a variety of reasons. 1, you start to become really desensitized and you lose this urgency when you're dealing with a real issue. You also tend to see like operational overload and burnout from your on-callers, because if you're being woken up in the middle of the night for something you can't even fix, or maybe you have to switch context every time you're interrupted, that's going to easily build up with your on-callers and they'll just get burnt out. So what we recommend is, instead, if your alert needs immediate attention, it should be a page that you send. Otherwise, if it can wait, you should send a ticket. One common example I see is folks sending out pages if a server is running out of storage. Like, yes, that's really important, but it's not drop everything you need to do right now to get this fixed, right? Generally, it reaches some threshold that you can take care of within the next couple days or even a week. So for that type of alert, you want to set that as a ticket rather than a page. And then finally, one thing with monitoring alerting is that when you do get an alert, you need to be able to dig into this data that you've collected, such as logs and dashboards to investigate and figure out what's going on. And the next thing we want to look at is demand forecasting and capacity planning. So even if the cloud could scale infinitely, your CFO surely will care about the cost of running your service. So you need to plan for things like organic growth, which could be increased product adoption from new users signing up, or planning for inorganic growth, which comes from just launches and new features that will consume more resources. And to be able to do this, you need to correlate the capacity of your service and resources consumed by it. And once you know what that is, you'll be able to do better planning in terms of when to put in purchase orders for additional resources, or even when to expand your service regions. And also, this helps to prepare you to handle events that you know will use a lot of capacity. In the United States, we have major shopping holidays like Black Friday, Cyber Monday, and I mean, even televised events like the Olympics. If you're in the media, you need to be able to handle these events because you know they're going to take up a lot of capacity. And the other side of capacity planning is efficiency and performance. So let's tie this back to SLOs for a moment. It doesn't make sense to have your service run faster than it needs to, because then you're just going to be wasting resources. Your customers probably won't care about the added boost in performance. And that's especially true if they were already happy with your service. And then on the flip side of this, it really doesn't make any sense to have your service run at 110% utilization. That just will have your latency degrade, and then all your users will be unhappy, and then you'll just be burning into your error budgets. So you want to strive for something in between here. And also, one thing you want to do is watch out for regressions. You can do this by detecting when your error budget is threatened and then adjusting capacity then. Although one common generic mitigation we like to use is if you detect that a new release is causing a problem, just roll it back rather than throwing more resources at it and seeing if it just will fix itself, right? And the next thing we want to look at is change management. At Google, the majority of our outages are caused by changes to a live system, whether that's going to be a new binary push, whether that's a new configuration push. And we're constantly making changes to our systems. So how are you going to manage this risk? Well, one, we try really hard to avoid making global changes. Instead, we do progressive rollouts over hours, over days. And another thing you really need is really good monitoring. This helps to quickly detect issues so that when you do have a bad release or you do have a bad change, you're able to quickly see the problem, detect it, and alert somebody to it. And another mitigation, like I mentioned, is having a way to do safe and quick rollbacks. So these are just some of the best practices. But I mean, like as engineers, what we want to do is to automate a lot of the stuff that makes it possible for humans to make human errors, like making a typo or accidentally pushing something, right? So while all that stuff is good, you should be working to try and automate as much as you can here. And good change management really is about managing risk. And the approach we like to use is just to try to make everything a routine process or a standardized change. For example, let's say your standard change pipeline involves an engineer writing some code. They have to get it reviewed. They have to get it approved. It gets picked up in a release package that operates on hopefully a predictable schedule, goes through some testing, goes through progressive and canary rollouts to your fleet. And now if if something went wrong with this release, you know kind of where it broke in this process to go to that specific component and fix it. One thing to note here is that the goal isn't to break anything and go slow. That's really the opposite of what we're trying to say here, is that you should try to go as fast as you can, try to increase your development velocity until you exhaust your error budget, and then you need to work on your reliability. And then at this intersection of change management and capacity planning, we have provisioning, which is about quickly and safely changing the size of an existing service, whether that means removing or adding additional instances or locations. And we really want to be as efficient as we can, because unused capacity is pretty expensive. Another thing we want to do is, depending on the change, it can be pretty complex, which means it's risky, and preferably you want automation to take care of it because it has to be handled carefully. And the fourth key responsibility of SRE is emergency response. So what are you going to do when something does break? Let's say you're on call for a multi-billion-dollar service and you start getting pages that the service is down. I don't know about everyone else here, but for me, that's a pretty stressful experience. So it's important to have a well-defined process to manage incidents. And it's really important to practice these on-call, these processes with like on-call training, such as disaster recovery testing or wheel of misfortune exercises, so that when you are faced with a real incident, you don't panic and you really focus on what matters, which is restoring the service to a healthy state. And really, once that's done, then you can start working on the long-term work to do the troubleshooting, figure out the root cause, fix the actual problem so it doesn't happen again. And one really important thing with emergency response is that it's really a team effort. The larger the incident you have, the more people you need to pull in. Obviously, you need to pull in SREs, but also development teams as well. Google's incident response protocol is actually based off of a real-world incident response system used by medical services, used by firefighters and crisis responders. And a key part in both systems is that you pull in the right people to help when an incident occurs. And you also delegate these tasks, and you spend more time to like focus on this planning process to have a more efficient response. And one of the most common failure modes I mentioned is that I see people that just don't pull in help when they need it. And oftentimes they're just really caught up in trying to resolve an incident that they don't even realize that they need, or even think that they need help, right? And oftentimes, other times you'll see that maybe they think they have to be responsible for the whole service, so they don't ask for help. And when this stuff happens, like the incident will just grow, you'll start losing more revenue, the impact gets larger. So an important part of the incident response process is that you need to define what the incident thresholds are. When are you going to declare an incident? When are you going to bring in other responders to help? You could use thresholds such as the amount of data you've lost, like I mentioned, when customers are leaving, the amount of revenue you're losing. But preferably, what we look at is the amount of damage you've done to your SLOs, how much of your error budget you've consumed. If you notice that you're on track to blow out of your entire error budget for the quarter in the next couple hours, you probably want to declare an incident. On the other hand, if it looks like the error budget isn't at risk and you have it under control, you can probably spend a few more hours to look at what's happening on your own. But bottom line is that it's really important to define these thresholds ahead of time, so when things do go wrong, people don't have to worry and figure out whether they need to declare an incident, right? You don't need to waste that time. You don't need to let the incident impact grow more than it already has. And then after an incident occurs, your focus really should be on preventing the problem from happening again using postmortems. So you want to make sure that you've really figured out and understood the contributing root causes to the problem, and you're planning work to improve the reliability of your service. Generally, the preventative actions that you come up with will be slotted into two categories. One is preventing the recurrence of the same problem from occurring again, and then the other one is to mitigate future incidents caused by the same class of failures. For example, let's say your service went down because of a bad configuration change and you couldn't easily roll back. One action item here is to add an integration test to catch this failure before it happens, thereby preventing the same exact outage from occurring again. And then maybe you make another action item to get an automated rollback system in place to help mitigate future bad configuration changes for other parts of your service. And then finally, the critical thing with postmortems is having a culture of blamelessness. Everybody's going to make mistakes. Humans are never the cause of incidents, even though that's kind of what we tell ourselves. That's not the problem. The problem is that your systems allowed you to make these mistakes. For example, such as giving everyone access to make critical changes, even though they don't need to, or you want to make sure proper approvals are in place for a change to happen. Remember, within SRE, we treat operations as a software engineering problem. So when things do go wrong, we look for the flaws in our system that allowed them to happen in the first place and fix it so we can avoid those human errors in the future. And really, if you want to learn everything you can from an incident, you're going to need to be able to get to the bottom of things. You need to talk to these people who may have pushed the bad levers to make things have failures and things like that. And you really can't do that unless you have a culture of blamelessness, because then people are just going to be scared to speak up. So this is really important. And the last key area of SRE is a cultural one. So this is the ability for SREs to regulate their operational workload. And when I say operational workload or toil, I mean, like, this is the stuff that is needed for a service to run that sometimes is manual, it's repetitive, it's automatable, even though we still do it manually. It scales linearly with the service. And often, like, it's not very fun, but it's really important because it gives you the experience you need to improve your service, to design better systems. And honestly, it tells you what you need to automate. If you're doing something, if you're doing the same thing to fix a problem every single day, that's a pretty good indicator that this needs to be automated, right? The thing is, you also can't automate everything because there's always going to be more work. But if all you do is operational work, you're no longer an SRE. Actually, at Google, we have a strict policy of capping the amount of operational work to 50% of somebody's time. So it gives them the rest of their time to work on project work to automate the operational tasks that they encounter. And as I said, SRE is really about treating operations as a software engineering problem. So that means you have to hire people with software engineering skills. That's not to say go out and, fire your team and just hire only software engineers, right? What you want is to have that, at least what's worked best for us, is to have a mix of software and systems engineers. So systems engineers typically have a pretty good, a holistic approach to the entire infrastructure of your software system. And they have a really good understanding of how software is deployed on specific hardware, and they're able to piece together different products from different teams to make them work together. And each of these software engineering and systems engineering practices, they really bring a different, but it's a needed perspective to the role. And it's really worked well for Google. And then finally, I really want to emphasize that empowering SRE
Can you start again? Sorry, I just wanted to make sure that everyone can hear you, please.
Sure, just start from the beginning of the slide.
Yes, so let me see. Can everyone hear us, please?
Mic test, 1, 2.
No sound.
Oh, weird.
Let me talk to our engineer. So Jay is checking. Hopefully we'll have that back very soon.
That's okay. I was going a bit fast anyway, so this is going to be perfect timing.
So just checking with our customers. Seems like if we can start again. It's back. Wonderful. Okay, wonderful. Thank you. You can keep going on that slide because I think they lost you for a minute. So thank you everyone for your feedback.
Okay, cool. So I'll just go start from the beginning of the slide. So I just want to recap our SRE practices I just talked about. So for metrics and monitoring, we want to measure our reliability and how well we're doing against our targets. We want to collect data that will help us investigate these issues with logs and dashboards, right? And then for capacity planning, we want to forecast demand to prepare for increased adoption of our service. And we also want to plan for events such as major shopping holidays where we might see a spike of 10x normal usage. And then we also want to find the right balance of performance and efficiency. For change management, we want to have a standardized release process in place to help reduce our risk and also implement progressive rollouts and have some automation in place here. For emergency response, we want to make sure our on-callers are trained so that when an incident happens, they know how to respond. And then after an incident happens, they know how they can prevent it from happening in the future. And the last one, with a cultural change within your organization, we want to work on toil so we can automate the processes here. And we also want to have the ability to regulate our toil, as well as a cultural change for having a culture of blamelessness, so that we can effectively write postmortems and really dig into the root causes of an incident. So these are the 5 key areas we talked about with the key practices to implement SRE. And you can also have these on your team even without having a separate SRE team. Like I mentioned, SRE teams will come in all sorts of shapes and sizes. And we've really found that these practices are valuable in supporting our engineers regardless of what role they have. So going back to the slide of SRE implementing DevOps, we can see that combining SLOs and error budgets and the key practices we've talked about, we give you this full implementation of the DevOps interface with how SRE implements it.
Okay, so we have thrown a lot of info at y'all so far in this presentation. We've talked about SLOs, error budgets, and those 5 best practices of SRE. So here at the end, we wanted to zero in on how to get started with SRE. So we're going to recommend that you do these 4 things. 1, define an SLO. It's really the very first thing you need to do to get started with SRE. If you don't have a measure of reliability, you have no idea how reliable your service is. And remember, you can start really simply here and iterate to improve over time. 2, you need to hire people on your operations team who write software, or upskill people on your existing operations team. This really isn't an either or choice. You can really do both at the same time. 3, people working in operations need to be enthusiastic about automation, and they also need to have parity of respect with the product development and software engineering team. And finally, you have to have that feedback loop for self-regulation. So you need to have people who can pick their work and people who are able to push back and say, you know what, we can't really support this new product right now because we're overwhelmed with the products we're already supporting. Here's your pep talk that you can do this. Really think about this as starting small and letting your approach to SRE grow. So we recommend that you start by picking just one service to run according to the SRE model. Empower the team with strong executive sponsorship and support. Foster the right culture. Measure reliability. And finally, don't shoot for perfection. Just aim to improve over time. And once you have a success, build on it. So spread the word. And really, in our experience, other parts of your company are going to start lining up to learn how you did it and see how they can do the same thing. So we really think that SRE is an effective way to be reliable in the cloud. And here we think two arguments really matter the most. So the first is the idea that effortless scale shouldn't mean you also have to increase the number of people working on operations, because otherwise your teams are going to get buried in operations. So if you focus on prioritizing for operability and reliability, your services can really run better without needing more people. And it's also important to highlight that you don't have to have this tension between product development and operations. Instead, if you're able to agree on whether the system is reliable enough, and then choose whether to invest in more features versus more reliability, then you can make that decision at any point in time by mutually agreeing, rather than playing tug of war and arguing with each other. So finally, here's a plug for some books we think will probably be of interest to this audience. The first two books on this slide are books about SRE written by Google. The third one is a really great book edited by David Blank Edelman. It's not Google specific, but has a lot of chapters about SRE from practitioners across the industry. And finally, that last book is the book about reliability and security that just came out in April. I also work a lot on external publications for Google SRE. So if you want to check out a lot of other stuff we publish, you can go to google.com/SRE.
Awesome. And I think with that, I'll go ahead and give it to you, Ingrid.
Thank you. Thank you very much. Excellent presentation. Was very excited to hear and share with our customer your best practices, Google best practices. So right now, we do have a lot of questions. So if we move to the YouTube live chat box, we can see that and we can start answering. So Cindy, Betsy, if you wanted to start with the number. I know Ryan was also working on a doc for all of us to look at the question, or we can go directly.
Just looking at the comments, it looks like the first question I see is, any advice on how to transition from a mostly manual QA role to an SRE role?
I can take this one.
Okay.
So going back to the key practices I mentioned for change management is that we really want to have a standardized process. And when you do stuff like QA, you do have a standardized process, but it sounds, if it's mostly manual, you're checking boxes and you're running through a list of things you have to do, right? That's what having an automated change process pipeline really is about, and just focusing on what things you can automate, what things need to happen so that you can run these tests, so they do the quality integration tests that you need before you push out a release. And even like after you set out a binary and things like that, you have some sort of testing in place on your system, like rollouts, progressive rollouts and canaries, so that you can see these changes and then you can stop the rollout, roll back, and then make the updated changes. So my advice here is to look at your pipeline, try to automate it as much as you can, try to standardize it so that when you do these change managements, when you do these QA analysis, that it's something that you can automate. It's a good first step.
Let's
the
see.
next question.
I see. Does SLO include planned scheduled downtime? So SLO should be all of your downtime. And I think one interesting aspect of this is that you also need to make sure, A, you want your SLO to be aggressive enough that you're hitting your reliability goals. But if you are constantly performing better than your SLOs, you might need to check yourself, because you don't want to set expectations with your customers that are above what you really intended. So actually at Google, we will schedule extra downtime sometime if we're really setting unrealistic expectations with the service for our users so that, if it's running at 1.9, they don't actually expect 4 nines and then freak out when it's 1.9. So I would say a key goal here is making that your SLO actually reflects user needs and expectations.
There was also a question before that that says thoughts on how to sell SRE to developers. And I wasn't quite sure if this meant to sell SRE and the concept of SLOs and error budgets, but I actually run into this problem quite often. So my role is to work with external Google Cloud customers and get them to adopt SRE. And one of the pain points we see is that, yeah, SRE sounds really great on paper, but no, our developers don't want to stop their releases so that our operators can have a better time at their job, right? I get that all the time. And the thing is, you really need to have executive buy-in so that there's a top-down leadership change throughout your company where people can be held accountable from all stakeholders to implement SRE. So that's really how we sell SRE to developers, is that you have to get buy-in first from your execs.
Let's see, now we have, can several metrics like response time aggregate to one SLI? Let me say I have a website with 5 pages and measure for every page the response time. Can I aggregate these 5 response time to one SLI? Cindy, I'm going to hand this one to you because you work with customers to develop these. So
sure. So one common thing I see is like latency response times. Let's say if you're measuring when it takes a customer, how long it takes a customer to get a response from opening your website, right? You have the first 90% of customers that fit into this bucket, and then you have the long tail or like the last 10%, which may take even longer. So what we do for response times and latency is we actually bucket them into thresholds. So maybe the first 90% has to get a response in under 100 milliseconds, and then the tail end has to get one within 5 milliseconds or 500 milliseconds. So you can aggregate it that way into one latency SLI if you bucket them like that. I think that answers that question.
okay, next up we have, how do you define an SLO for a service that only needs to be available during business hours? So for example, excluding evenings, nights, and weekends. Yeah, so this is definitely something people need to do. And we emphasize that SLO is the availability during, just a given time window. It doesn't have to be 24 hours. I think if you take a look at the site reliability workbook, so that second book on that slide, which is available for free online, there's a whole chapter on implementing SLOs, which is chapter 2, and that walks you through a bunch of different worked examples. And I think that would be a good place to get started with doing that.
I think the next question is, how quick is quick rollback? So if it leaves data in an inconsistent state and requires manual updates, how do you decide between rollback or accept risk and mitigate? So ideally, when you roll back, it has to be to a last working state. And honestly, like, you should be testing your rollback mechanism
what
I love the sound again, ladies. I truly apologize. This is very unique. So let me work again on trying to get the sound back.
Okay.
So I'm seeing a customer feedback. So can you hear me now? Sound is back. Okay,
Yeah.
we have yes. Thank you. Sorry for that.
Okay, so we were looking at a question about Stackdriver and what list of metrics to have on the dashboard along with the computation details. So Cindy, do a lot of the customers you work with use Stackdriver? And like, what are the logistics of that are relevant to this question?
I know Stackdriver does publish a list of metrics that are available that you can use for your dashboards. It should be, it's like a page that like lists like hundreds of metrics. So I think that's what this question's asking, unless it's asking specific SRE thing. I actually would need clarification, but if you're looking for a page with metrics on it, we do have one.
Is Google maybe considering having some official complete academy to prepare external people who are interested in becoming an SRE? So as far as I know, there's no plans to have some centralized academy with all training things at SRE, but we do have a lot of training things available online. Like Cindy, CRE has some Coursera courses, right?
Yeah, we have one for specifically making SLIs and SLOs. If this question is directed more towards like what practices and things like that you need, I don't think there's anything that we have available.
So another good resource to go to is that website I mentioned before, which is google.com/SRE. And on there, you can see a list of, in addition to everything we publish, there are some trainings on there, and there's a drop down you can filter by for trainings. So that's another good site for Google trainings.
I also, it's not SRE, it's the job title SRE, but we do have something that my team worked on or provided input on for the professional cloud DevOps engineer. Like I said, we come to the same solutions and we just implement it slightly different, but that might be something that more aligns to this question. So it's called Professional Cloud DevOps Engineer.
And I know too, the like SRE Con conferences usually have an initial day that's just focused on trainings. So that's a really great resource to just hone in on a bunch of stuff in a concentrated amount of time. Like obviously there aren't physical conferences happening right now, but I'm pretty sure there's going to be a virtual conference in the fall, maybe. I would just Google SRE Con. Next question, why do you use the term root cause? Even with plural, it's more confusing.
I think when we're generalizing like an incident, you have like a trigger, or maybe you have multiple triggers that happen. And trying to think of an example, like if someone was able to push a bad binary, the root cause here is one, giving people this access, right? Even though there are other triggers, such as maybe the automation, or maybe they could bypass approval processes, or maybe the release shouldn't have let them do that in the first place. But the root cause is generally like restricting this access. So I'm speaking more of a generalized term. Sure, you can have multiple triggers. You can have things that will start the event. So I guess it was more using a general term. And then lots of comments on about audio.
Yes, there are some really good puns on reliability and SLOs there that I would just like to say I bring joy. I see a question further down about Jira. Do you know anything about what we might be doing with doing or not doing with Jira, Cindy?
I'm still in the audio comments, so I'm trying
Okay.
to find out where that is. Sorry.
I think it's
Nope. Can you read the question out? Sorry, I can't find it.
says, are you planning to build some kind of software products around it? I'm not sure what it is, but like Jira.
I don't know how Jira implements. I'm making an assumption that they are referring to having SLOs and SLIs framework on Jira. If that's not the question. We do have something similar. It actually is in public beta right now, and it will be available sometime. I don't know, but I'm guessing that's what the question was.
Okay. And we're at 3 minutes till, and we promised to hand it back to Ingrid so she could close out before we're completely out of time. So, Ingrid, over to you.
Thank you, Cindy and Betsy. And thank you to all the customers for asking such great questions. So we want to thank you for your time. So as soon as you check in, we'll be able to, because I saw a lot of questions around getting slide, record session, as well as digital copy of the books, right? So everything will be available to you as soon as you check in. You send us your email, so you give us the permission to send you information. I really enjoy the conversation. Every Wednesday at noon, we'll be having the same conversation, and also with your feedback on different themes that you wanted to discuss with Google. We love to hear, and please do not hesitate to share with us question, feedback. We learn from you and with you. So with that said, I want to thank all of you for joining Google Cloud today, and I wish you a safe and great week. Talk to you very soon. Bye.